Good evening, young scientists.
Good
evening,
Miss Park.
How are you doing today?
Good.
Good. So yesterday we briefly talked a little about how to conduct scientific experiments and how to apply the scientific method to our research. Today we're going to talk about one of the steps of the scientific method, which is writing a scientific hypothesis. Can anyone tell me what a hypothesis is? Grace, I guess. Very close. So a hypothesis is an educated guess. It is an informed prediction of what we think will happen because we don't want to just guess. There's no scientific basis off of guessing, and as scientists, we want to make informed decisions to gain more knowledge. So an educated guess brings together everything we already know, like gravity or radioactivity, and gives us a direction and a goal to pursue new knowledge. So how do we make a good hypothesis? Well, a good hypothesis must have 4 things. It must be clear, specific, measurable, and reasonable. Here we see 2 hypotheses. Food tastes good, and if we add baking soda to vinegar, it will fizz. Here we could see clearly that food tastes good doesn't really outline what we want to do in our experiment. It's not specific or clear. It doesn't say what kind of food we want to use or what good is. But here, if we add baking soda to vinegar, it outlines our exact materials, baking soda and vinegar, and what we think will happen, which is the hypothesis, really. It will fizz. So here we have a specific goal saying we want to see this baking soda and vinegar reaction fizz. But here, we don't really have an outcome in mind. So that takes care of clear and specificity. Also, it must be measurable, qualitatively or quantitatively. Here, fizzing is a qualitative measure, and we could see from just our eyes that it will fizz or it will not fizz. But other reactions or other experiments could also have quantitative measures, like this scale can measure weight, and this beaker can measure volume. And we can take that data and make conclusions off of that. So we covered clarity, specificity, and measurements. And it also must be reasonable. So because we're not NASA, we can't fly out to Mars and conduct experiments there. Also, we also have to be ethical with our experiments. So we can't steal our neighbor's cats and be mad scientists at that either. So here, baking soda and vinegar is pretty innocent, but it's also for a scientific pursuit, and it will lead us to more questions like, why does it fizz? And what happens between the baking soda and vinegar? And ultimately, that's what a good hypothesis does. It takes a question, and then after we test it out, we come up with more questions, and then we can repeat this whole process over with making more hypotheses and carrying out more tests. Okay guys, that was a fun lesson. So now let's do a chant to review all the concepts we've covered in class. You guys ready?
Yeah.
Okay,
Let's
so
do it.
just repeat after me. We are scientists.
We are scientists.
Mighty, mighty scientists.
Mighty, mighty scientists.
Everywhere we go.
Everywhere we go.
We always want to know.
We always want to know
How things work.
how things work.
So we make hypotheses.
So we make hypotheses.
We make them clear.
We make them clear.
We make them specific.
We make them specific.
We make them measurable.
We make them measurable.
We make them reasonable.
We make them reasonable.
Because we are scientists.
Because we are scientists.
Mighty, mighty scientists.
Mighty, mighty scientists. Yay!
Yay! I don't think
Go
so.
science.
Yeah.
Yeah.